All right, everyone, ready to jump back into some algebra. We've got a lot of notes here on Algebra 2, polynomials and polynomial functions. And there's a ton to unpack, so let's just dive right in.
Yeah, it might look like a bunch of random symbols and equations at first glance, but trust me, once you see how these concepts connect, it's like unlocking a whole new level of problem solving, not just in math, but in real life, too.
That's what we're here to do today, right?
Anyway.
Unpack this stuff and make it make sense.
Absolutely.
So let's start with something that caught my eye in the notes, polynomial operations. Now, I got to admit, that sounds a little intimidating. What exactly are we talking about when we say operations with polynomials?
It's actually simpler than it sounds. Think of it like this. You know those building blocks, Legos?
Yeah.
Each term in a polynomial is like a different Lego block. Adding and subtracting polynomials is like combining those blocks, grouping the ones that are the same together. Multiplying, on the other hand, is where you start building more complex structures. You're connecting the blocks in different ways.
So, okay, we're building with Legos, but then the notes jump to factoring polynomials, which sounds like we're taking those Lego creations and breaking them apart. Why would we want to do that?
Ah, that's where the real magic happens. Factoring is like finding the secret code of a polynomial. It's essential for solving equations. You see, when you factor a polynomial, you're breaking it down into its simplest components or factors. And those factors hold the key to finding the roots of the polynomial.
Roots?
Yeah, the roots are the values that make the whole polynomial equal to 0. It's like solving a puzzle by finding the missing pieces.
Oh, so factoring helps us find those missing pieces, and those pieces are like the keys to understanding the polynomial.
Exactly. Got it.
Got it. Okay, so we've built our Lego creation, we've taken it apart and found the secret code, but then we shift gears to graphing higher degree polynomials. How does visualizing these equations help us understand them? I'm a visual learner, so this part always intrigued me.
Graphs are super helpful because they give us a visual representation of how the polynomial behaves. We can see how the output or the av value on the graph changes as we change the input or the x value. And the degree of the polynomial, which is the highest power of the variable, it determines the overall shape of the graph. Higher degree polynomials, they lead to more twists and turns in the graph, which makes them more interesting to analyze.
Oh, okay, so the higher the degree, the more complex the graph.
Exactly.
That makes sense. So we've covered operations, factoring, and graphing. Now we come to these two theorems, the remainder and factor theorems. I've always found these a bit mysterious. What makes them so important in the world of polynomials?
These theorems are like shortcuts. They give us insights into polynomial division and factoring without having to go through the whole long division process. The remainder theorem tells us what the remainder will be when we divide a polynomial by a linear expression.
So we don't have to do all the long division.
Exactly. It's a time saver. And the factor theorem builds on that. It tells us if a specific linear expression is a factor of the polynomial just by checking if the polynomial equals 0 for a specific value.
Oh, wow. So these theorems are like little helpers that make working with polynomials easier.
Exactly. They're essential tools in our polynomial toolbox.
I love it, a polynomial toolbox. So as we wrap up here, I'm starting to see how all these concepts connect operations, factoring, graphing, and these theorems. It really does paint a more complete picture of what polynomials are all about.
Absolutely. It's like we've assembled a puzzle. Each piece, from those basic operations to more advanced theorems, contributes to a deeper understanding of polynomials and their applications.
And the real satisfaction comes from seeing that complete picture.
Exactly.
Well, thanks to this deep dive, I think we've successfully put together that polynomial puzzle. We've explored how to manipulate them, break them down, visualize them, and even use some handy theorems to make our lives a bit easier.
And, as you continue exploring math, think about how these principles might apply in other areas. Could similar theorems or techniques be used to analyze other types of functions or even model complex systems in the real world? It's an interesting question to ponder.
That's a great point. It's all connected in some way.
Right.
Well, folks, thanks for joining us on this journey back into the world of Algebra 2. Until next time, keep those mathematical minds engaged.
Absolutely. Keep exploring.